Hello, everyone, and welcome. With us today, I have Ramya Oraganti. Ramya, welcome.
Thanks, April. Thanks for having me on the show. To introduce myself, I'm Ramya. I'm currently working as a PM with Azure Functions. So my focus areas are enabling functions on Kubernetes-based environments like Azure Container Apps, AKS. I also work on these event streaming triggers like Kafka, Event Hubs, RabbitMQ, and SQL. Apart from this, my team and I work on this OSS component called Keda, which helps with scaling of containers dynamically based on the events. So yeah, thanks again for inviting me to the show.
I'm really excited to have you here. I love cloud native development. It's near and dear to my heart. And today we're going to cover off cloud native development, but more around Azure functions on Azure Container Apps. So we're going to make our functions completely scalable. And we're going to integrate some really cool developer practices using some of the GitHub tooling to make onboarding much easier, specifically around cloud native technologies. Because Ramya, you and I were talking about this content, and I remember you and I sitting there going, it's so hard to get started. We have all these blockers, we have port issues, we have all these things. So we're going to show everyone out there how we were able to get started pretty seamlessly and start developing with Azure Functions. So I'm going to let you go ahead and kick it off and take it away.
So let me start with what Azure Functions is, right? So Azure Functions is a serverless solution which offers an event-driven compute experience that allows developers to write code in the language of their choice. So they can connect to other services without hard coding integrations. This enables faster development. They could use triggers and bindings that come out of the box with Azure Functions extensions. So Functions offers an end-to-end inner and outer loop dev experience for developing, debugging, build, deploy, and monitor. And it also supports on major platforms like Linux, Windows, and macOS. So developers get to build once and deploy to multiple destinations, like on managed service in Azure using one of the Azure Functions hosting plans, like consumption, Elastic Premium Plan, or App Service Plan. Or they could deploy on AKS or Kubernetes hosted in an IoT device or another public cloud or a Kubernetes cluster. And they could use a functions host, open source functions host and runtime images. And the function apps can scale on demand, and you get to pay only for the time you execute the code. So Azure Functions allows users to maintain less infrastructure, save on cost, instead of worrying about deploying and maintaining services.
And I think I've used Azure Functions so much to connect services, to do things that I might have automated using a whole server. And without having to do that now, being event driven, the fact we're going to make them scalable, I think, is even more powerful when we're using functions. So
Yeah, absolutely. And I'm gonna like in this session talk more about like event-driven in this cloud native and microservices type of environments. And we recently launched uh, Azure Functions for microservices in public preview during the Build conference. So this is a new hosting environment option that will be available, and it enables developers to quickly build event-driven cloud-native function apps with the flexibility to run functions along with other microservices, APIs, websites, workflows, or any container-hosted programs. And Azure Functions integrated programming model still it supports, and you could leverage triggers and bindings that come out of the box and pick the language of your choice and integrate with other APIs and apps of mixed programming languages as such. And the promise of true cloud native experience is about managing with DevOps processes and tools, which is already offered by Azure Functions, right? So you can use the same tools and management experience that you're already familiar with using Azure Functions, and you could deploy the code to cloud through the CI/CD tools like GitHub Actions and Azure DevOps pipelines. And then you can easily integrate, right, with multiple app types. Like say, for example, you have a web app, a function, and an event source, and all of them could be hosted in containers. And you'll be able to integrate, build, and deploy all of them together using ARM or Bicep templates. And apart from this, developers can also leverage technologies like Dapper to kind of weave in these apps together, which enables users to build resilient, secure system. And they could leverage these best practices that Dapper offers for distributed application development. And finally, as you can see, like you need not worry about managing this underlying infrastructure, like configuring the network separately for each app or observability, because these are all shared by all the apps that are deployed into this app environment called container app environment.
yeah, and I think everything's hooking in to be completely resilient as well, which is really important. And it's code first, fully resilient, and not having to maintain a huge infrastructure underpinning what you're doing. So it is that seamless end-to-end development experience.
Absolutely. So you get to focus on code and not really worry about, managing and maintaining that underlying infrastructure, or even, the Kubernetes layer. So you need not really learn about these control plane, kubectl kind of APIs to kind of manage your Kubernetes clusters. Or like you could focus, bring your apps that you're familiar with while deploying to app servers or function apps, and deploy these apps onto, by selecting this hosting environment and deploy them. And from also like to touch upon the scaling, right, aspect of it, right? Like function apps can auto scale all the way to zero and they become inactive, or they can scale to dozens of containers under high load. So which means if there is, it doesn't get any traffic for a number of minutes, the pods are scaled all the way to zero. And when they are zero, like users don't have to pay for these containers as such. So users get to pay only when the containers are actively processing requests. And this is possible using the consumption plan support. So in this scenario, there's, you don't pay extra for, running Azure functions on container apps as such. So because these functions executions are built according to the container apps. And apart from this, you have the option to set min replica count to 1. Let's say if you want to have that, optimum cold start experience, and if your applications have a very high cold start requirements, then you could set min replicas to 1, where there are containers always running, and you could get to pay idle price when the replica is inactive. Because there's a certain threshold that the service looks for, and if it is going beyond the threshold, that's when the active pricing charges. So you can kind of mix and match and deploy your containers as per the requirements of your applications.
Absolutely.
And coming back to the yeah, and coming back to the scaling, right? So scaling happens due to the load or messages in the event sources like queues or event hubs or databases. And KDA is that open source tech that is making this happen. So with seamless integration with functions on container apps and KDA, you need not explicitly configure these scaled objects like you do in AKS or a Kubernetes cluster. So these will be auto-configured for you in functions for ACA hosting. To, as you can see, right, we are trying to kind of get you started very quickly in deploying these functions and running these function apps. And a function provides various plans and options to deploy functions as per your business needs. So if you have requirements to deploy these apps as containers running alongside with other microservices in a mixed environment, then functions for container apps is the plan that you could consider.
Absolutely. I found them in Azure Container Apps when we announced, when Microsoft announced Azure Container Apps and the ability to put your function there, it was totally a game changer because I remember having cold start issues with functions. The consumption plan wasn't as verbose as it is now. There's definitely been so many great features put into Azure Functions around that. And I remember even just designing systems for customers in AKS, like containerizing their function and trying to mitigate the cold start. It's become so much easier with the consumption plan and be able to hook in things, other open source tooling to just make these more event driven. And again, not have that cold start that we used to have. And that's also been an issue when you ran things off a server, right? Capacity, compute, planning, and all that. Now it's so much easier to say we need one in reserve, ready to go, avoiding that cold start issue we had, and then scale that out as we need to. And we see systems that are, very seasonal or time based on certain times of the day, ready to go and can scale these out. So it's an awesome way to do cloud driven development with microservices for organizations and enterprises.
Yeah, absolutely, April. And this is getting better as we progress within the all the SKUs that Azure Function supports today, right? Like consumption, elastic premium. So the algorithms are being continuously improved so that to mitigate these cold start issues for any SKU that the customer is choosing. So it's like a fundamental platform thing that we plan to offer. And the user need not really worry about configuring or provisioning instances with which cannot take cold start issues as such.
And I think for everyone out there as well, just real quickly, we have a link to the announcement for the public preview. We'll put the link in the description, but this is also the link that you can follow to look at how, to look at the public preview post that you guys put out about the new features.
Yeah, thanks, April, for that. And Now I'd like to really emphasize on the type of use cases that users can consider and the type of personas that we believe could benefit out of this, right? Like cloud native developers, backend developers, or data scientists could deploy their workloads on this microservices kind of cloud native environment. Like they could have a mixed workloads, right? Like they could have functions and other microservices, and specifically for functions, they could leverage these functions on container apps type of offerings to kind of build those programs to react to events. And these events could be coming from HTTP, Kafka, or Event Hubs, and invoke another web or Spring-based API that's already running in this container app environment. And they could scale these function APIs on demand as the events increase. And this is possible, like I mentioned, using the seamless integration with Kada, and they could use the triggers and bindings with the language of their choice. So these personas can also deploy certain web services like RESTful APIs in the backend with event-based execution requirements. Let's say, for example, authentication APIs, right? Like they trigger during these login events or authorization events, and this the HTTP triggers can be put to good use here. And we've also seen customers use event-based data ingestion platforms to perform these data quality checks, let's say for online retail or e-commerce or travel apps. So this data ingestion platform with these data quality checks helps validating data for accuracy and completeness. And this and once so this and these are very ad hoc and event based. So only when the data comes into this event platform or the ingestion platform, the the, the function has to be invoked. So that's when you could use like the Azure functions on container apps, and the functions get invoked and they perform all these activities, and they can in turn invoke these ML workflows once data quality processing completes. So again, Kafka triggers or Q triggers using the CI/CD tools, and the consumption plan can be of possible options to consider in such a scenario. And then finally, the IoT or point of sales or smart devices, which are constantly sending telemetry data, right? And they need to be routed to other units for processing. So these events could land into a Event Hub service or Kafka topics and functions triggers running on these containers in this app environment could be invoked, and they pick these events, the telemetry events, and pick them up for processing and transfer them to the downstream systems as such.
Very cool.
So now
Yeah,
let's
I think that is the reality. We have multiple personas in every single deployment we do. It's not straightforward
yeah,
anymore. So this is a great real life use case of all the things involved and how we can then trigger that and bring that all together.
yeah, absolutely. And I think now let's see how to deploy these functions on container apps using Portal. So for that, let's go to the demo zone. So so here we are in the Create Function app portal page. So you go to the Basics tab and select a subscription and a resource group, and then give a name to your function app. Select the deployment mode as container, and then choose a region from the list of regions that are available. We'll go with East US, and then choose a plan as Azure Container Apps Environment Plan. So this is where the functions gets deployed into this cloud native microservices based app environment. And then select apps environment. So here you could choose from an existing list, or you could create new. So let me show you how to create a new app environment. So click on that link there. It takes you to the Create App Environment experience. You could select a name and then select a plan. So currently consumption V1 and V2 are two plans that are supported. The V2 plan is in preview. So you could choose from one of this, and then click on monitoring and choose a logs destination so that you could monitor the apps that are deployed on your containers. And then you could either choose your own virtual network or pick, and it could be an internal or external, but external one. But functions today support internal, and we are like very soon will be supporting the internal endpoints as well. So for this demo, let's go ahead and uh, choose the one that's already created, and then click on storage, and this picks a new storage account. And then from a monitoring standpoint, so we always recommend customers to choose this app insight so that they could monitor their function apps. And then from a deployment standpoint, so we have introduced this, they could choose a quick start image, or they could bring their own image. So if they have their image already, the users are expected to provide their registry details. It could be a private registry or a public registry. So if it's a public registry, just given the registry URL, or if it's a private, you'll have to enter the creds of your registry. Um, and now let me talk about the quick start image that we have actually introduced in this plan. So this essentially has a HTTP trigger to kind of let the customers quickly get started. And once they deploy, the HTTP trigger is already up and running. So hence we've kind of introduced this image. So I'll go ahead and choose that, and click on review and create.
So it's
So
interesting when
while
you talked about the networking. That's a hot topic right now. We're going to touch on that when we do our developer environment in a minute. But so often customers have the requirement for internal networking on their functions because they privatized or private VNets effectively. They can also control how their traffic is flowing, et cetera, not expose public endpoints. So that's been a huge change that's happened in functions over the last few years. That's been great to see because a lot of customers, depending on what industry they're in, whether in financial services, healthcare, government, it fulfills their compliance to have that private access. So that's great. That's really good.
Yeah, absolutely. Like customers tend to like build this VNet using the Azure networking service, and it's turned on as an internal one, and they kind of inject all their Azure resources onto this, and the all the communication is happening, like the communication that happens between these services is within the private VNet assets. So having that capability is key to, and it's one of our enterprise promises as such.
Mhm.
So yeah, so the options that we have selected to create the functions resource, you could see the summary here, and go ahead and create. Click on create. So while this is happening, let me show you uh, a resource that I've already created, which is essentially using a quick start image, uh, and so if you go to the functions here, so this is the function, the quick start image provisioned HTTP example that is out there, and it will kind of help you produce that HTTP URL link. Uh, so as it's loading, uh, you could click on uh, the get function URL, which essentially helps with the generating that URL as such, and could copy it and see it here. So as you can see, the HTTP function has been processed successfully. So now that you've seen this simple demo on how to quickly, provision this functions resource on Azure Container Apps. So now let me, get into a use case. Oh, I see that our resource got
Our
deployed,
new
and
function app's ready.
our function app is ready, and yeah, the example, the HTTP example is the one that got provisioned as such. All right, so you've seen how to kind of deploy this using Portal. Now let me show you a use case, right? Like in your organizations, you must be storing your scripts, code files, templates, some important docs at various locations. It could be a GitHub repo or cloud drives, and it could get very challenging to find these files through a single search across these locations, right? And you may end up spending hours to find them. So I plan to bring this search app that lets you easily find these docs, search for these docs by asking questions in everyday language. Right. So here, if you see the user first posts a query, using and the user is going to get this doc search web app, and this doc search web app is actually hosted on a container app, and it's running on this Azure Container Apps microservices environment. So in the same cloud native microservices environment, a function app is also deployed. And this is using the functions on container apps plan as such. And it's a HTTP trigger, which is written in Python. And this code is essentially using a text embedding ADA002 model, which is quite a popular model used for text search, text similarity, and code search. And it's happens to be like one of the good model, and it's performing and most efficient model that's out there. And this model is essentially hosted on Azure OpenAI service to search for files. And these files and their paths are stored in this vector DB. And the vector DB here, which shows is the PostgreSQL, and it's hosted on Azure database for PostgreSQL. So as you can see, the HTTP trigger function app is co-located with another microservices, which is a web app, and it can operate in a serverless mode, right? It actually scales to 0, but gets provisioned when the doc web search app invokes the HTTP URL, and it executes the model, returns the results, and scales back to 0. So let's look at the code now. So here, let me start this code space here.
So let's talk about this code space, Ramya. I want to take a minute and talk about the code space, because when you and I were getting started with Azure Functions, and anytime we do cloud native development, there's always questions like, are you on a Mac or on your PC? What device you're using? And you and I were talking, and you're like, I'm struggling with ports, developing locally in VS Code. So you and I kind of like tackled this. I'm like, well, let's spin this up in a GitHub code space. And I want to touch on the GitHub code space for everyone out there watching. What is a GitHub code space? It is your IDE in the cloud, effectively. It's in a containerized environment, and it allows you to go into that repository and spin up the code space instead of cloning locally to your machine. It was able to open up the ports I needed immediately. So where Ramya had a lot of problems in VS Code, I was coding away within a couple minutes from this code space. The other thing is this code space contains a development container, a dev container. So from there, it has everything pre-installed. So when you go to Ramya's GitHub repo, you're going to see all prereqs you need, certain versions of Python, etc. That's all built into the dev container that we're running. And that got us started really quickly. So we're running this dev container Docker file. It has all the prereqs we need to start development right away. We will share the link to this GitHub repo in the description. But effectively, we can get started right away. There's no delay, because onboarding any project is always tough. And also versioning, prereqs, all that good stuff. So Ramya is going to go ahead and take it away and just easily start making some changes in her code.
Yeah, absolutely. I'm glad that we had that, chat over, the challenges that I was facing when I was deploying it locally, and we kind of got it into the code space. And I exactly have the same environment like my local development. Like I see uh, like the exact Visual Studio code that I'm very comfortable, using. It's the same thing, and I need not worry about the ports and the networking aspect of it.
And you have all your settings synced across, I believe, as well. We sat there and set up a sync from your VS Code into the code space. So literally all the extensions, all the things you are used to having, whether they're linting tools. But there's also things we're going to show off in a second. So I think you're going to show off some features that you're doing directly from the code space. And for me, it's not changing that context, going out of VS Code to all the other places I need to go into to write my code. So yeah, I'll let you take it away with what you're doing.
Yeah, absolutely. And also, all the dependencies were already taken care using the dev container. So I had some Python, like I was using the fast APIs and some Python versions and the dependencies that needs to be installed. And the dev container on this code space kind of helped me with, installing all of them. And I was like, once the environment is ready, I'll also show you as we progress how quickly I was able to run the Python apps without installing those requirements and packages explicitly. So let me first go through the function app, right? So this is the entry point where the HTTP trigger, the function app gets invoked, and it essentially calls this ChatGPT plugin and under the servers folder. And the ChatGPT plugin essentially has few methods for deleting the request or querying the request from the data store, or inserting the records as such. So this kind of invokes the data store Python code, which essentially uh, queries, uses the model, the text embedding model, and queries the database and uh, returns the results back to the ChatGPT plugin.py. The other thing that I want to emphasize here is the GitHub Copilot chat.
Mm-hmm.
So this really helped me to kind of, create test cases. Let's say, for example, I want to check if the query method is working fine. So I have to just select this and uh, say generate a test case.
Yeah, I think
For
this is one of my favorite uses of GitHub Copilot chat is writing. I can highlight my code, put it in the box, ask GitHub Copilot chat a question and say, generate a unit test for me, and it will.
Yeah, absolutely. So as you can see here, uh, so it actually gave me a test case, to invoke this method and execute the query. So this is really like quickly put things together, and where I could quickly execute the test case as such. And we'll discover more. I'll try to share my experiences with the chat here. So yeah, let's so this is the code that's being used, and let me also go through the Docker file. So this with the help of the Docker file, like just to go through all the dependencies, right? These are all the dependencies needed to uh, containerize this code as such. So this was already containerized, and an image is being created. I kind of used the Docker build commands to kind of build this image and uploaded it to a registry, and it kind of helped me with getting the URL as such. So once the URL is generated, I'm ready to kind of go ahead and deploy the function app. So you have just seen how to deploy the function app using the portal. You could also deploy the function app using CLI as well. For this, you could use the command az function app create. And the only new parameters that we have introduced for this hosting option is environment. So the environment parameter essentially tells which container apps environment the functions resource needs to be deployed to. And you also need to provide the image and the registry details. Let's say if it's a private registry, you are expected to provide the registry username and password along with the uh, image. So, and this is my functions resource running on container apps, which is deployed. And as you can see, this is the HTTP app underscore func is the function app that is essentially hosting that ChatGPT plugin. Now let me go ahead and execute the sample. It's a Python code which is just triggering. It's like a unit test case, right? Like I'm just triggering this function which is available on this URL, right? This is running. It's exposed on this URL. So I'm going to go ahead and invoke that, and also I'll be like, there's a query that I giving it here to uh, give me the file which helps to convert this Excel to the SQL. So let me go ahead and execute this.
And while you're executing that, I want to point out something really cool that's happening. So you brought up in the portal when you talked about the internal VNet integration that's coming, new features that are coming. So currently GitHub Codespace is hosted in GitHub. We do have a new feature coming where private VNet integration is coming to GitHub Codespaces. So you're testing that public URL, which is pretty normal for us as developers, testing those public URLs. But in an enterprise space, we need to be able to have a private URL. We need to privatize that, keep that internal to the VNet for security reasons. So, yourself as the product group, very aware of that feature. It's coming. And then also the ability from a GitHub Codespace to use an internal VNet is also coming. So that means you can kind of do an end-to-end seamless integration of any of your Azure container apps, your functions, et cetera, all your cloud native development from within that privatized VNet, whether it sits in Azure or wherever it sits. So you can integrate that and have that secure connection across, which is huge because that's been an ask from customers for a really long time now.
Yeah, that's a good call out. And like you rightly mentioned, uh, so as we bring in the VNet internal capability feature, these endpoints will be exposed only, they will have private, they can be accessed through a private VNet only. And like you mentioned, if the code space is also providing that feature, so it's all using the secure networking environment, these APIs are being invoked and interacting or integrated as such. Yeah, that's definitely a good call out. All right, so you've seen how we've kind of invoked this HTTP trigger. We've put a query request, and it has essentially returned the path where this file is available, right? Now let us see how to implement the CI/CD tooling for this code, right? So yeah, so Azure Functions on Container App supports both GitHub Actions and um, Azure pipelines, right? So you could use any of these tools to set up your CI/CD pipelines. So for GitHub Actions, all you need is the the workflow YAML file. And so as you can see, I'm like, so presenting the YAML file here to set up the GitHub Actions. So all you need is to set up the Azure RBAC credentials, the registry username and password as the secrets in your repository, and then also provide your registry details and the target environment and the function app name so that the GitHub action pulls your image from the registry that you provide here and then deploy it to the function app as such. Okay, so I could go ahead and make a change here. Uh, let's say we'll change the payload, ask a different question. Uh, so find the Python dependencies file and click on commit, and let's commit to this branch. So, and so this actually triggers the actions. And before I go to the actions, I would also like to show you the settings page where you could set your uh, secrets, go to secrets and variables, and set your secrets that are needed to set up the GitHub actions as such. Okay. Now let's go to the Actions tab, and as you can see, the payload, I've updated this sample payload file, and this has triggered a pipeline which has a build and deploy stage. So this is in progress now.
The other thing you can do too from your GitHub Codespace is see your actions, write your actions from within the Codespace, and then see them running from within the Codespace. So you don't have to go back to your GitHub portal. So for those of you watching, you can have the extension installed into either VS Code or your GitHub Codespace and see as your actions are running, and you actually don't have to leave your IDE, which is really useful for, again, not context switching.
Yeah, that's a great call out, April. So that all your development and the CI/CD is happening within the code space as such. Um, so while the GitHub Actions is running, I would also like to touch upon the Azure pipelines, right? So here you'd need a pipeline YAML, which essentially has a workflow file similar to the GitHub Action YAML file, and this helps with here this helps with triggering your Azure pipelines as such. And here also you're expected to provide your registry, your namespace, and the image details, and then the target function app name and the subscription, so that the pipeline picks the image from the registry that you provide and deploys it to the function app. And since we've already made a change, we could see that the Azure pipelines is also must have also got invoked, and we could go to the pipelines, and see that the pipeline has been invoked, and it is as you can see, the update sample is in progress now. So once it's executed successfully, you'd see that it turns to green, and it kind of completes the build and the deploy stages as such. Okay, so you've seen how to deploy the functions on container apps, and we've also seen the CI/CD, integrating them with the CI/CD tools. So shall we now add a front-end app to this search plugin?
Let's do
Right.
it.
So for that, yep. So for that, let me go to this code space again. Okay, so we'll restart our code space, and so this code space essentially has the front-end app to the search plugin that we've just seen. So this is so it essentially has two important files, especially the CS HTML, which is taking the query input from the user and triggering the endpoint where the function is running, and directs the query into the function app to get executed. And then like I want to call out one thing here, right? Like I was facing these challenges to kind of get the actual JSON, because the query returns a huge JSON file, and I just needed the like one field in that JSON. So I ran into several challenges while getting that specific JSON field. So I kind of uh, ask the Copilot a question about, like, hey, how do I, like, can you give me what is the C# code to retrieve the source ID from this JSON, right? So so this is the JSON that I was talking about. It's pretty huge. It has several fields. So like you could go ahead and ask the Copilot chat about this, and it was amazing to see that it has actually given me the C# code to retrieve the source ID as such, right? So
It
this was
explains it for you, which is really helpful because you're stuck going, what is this? What is this output? What is it doing? And then it gives you that output, and then it explains it for you, which is awesome.
yeah. I literally had to just like copy this line and then paste it in my code and run it, and that's it.
Awesome.
It worked magically. Like it gave the exact output that I was the JSON field that I was looking for. Okay, so this app is also containerized, and it is deployed into the same environment as the function app is running. So so this is the app environment, the ChatGPT environment, where I've deployed both the front end app and the, let me, yeah, I've deployed the function app as well as the front end app here. So these are the two apps that are available in this app environment. So let me go ahead and click on the URL, which has the doc search app. So this is the app, and it's actually scaled to 0 because I wasn't using it. But now that it is invoked, it should be app. Oh, okay. So this is so I could go and say find the script to convert Excel to SQL and click on search, and it gives me the file where the path where uh, the file is stored as. And while this is happening, so this is where the function app is getting invoked, and it is executing in the background. It's actually calling the model, and it is executing the model and hitting the database and retrieving the results. So I could give more search queries to this, and it returns with the path of the files. And let me show you the App Insights live metrics, which actually uh, shows how the metrics are being collected for this, because we've turned on, if you remember, we've turned on the App Insights for this particular app, and So as we invoke the function app, the app is being traced and logged. So if there are any issues, you could check out the traces here to see, if the functions have been successfully executed or if there are any issues. And as you can see, like we have, invoked several or submitted several queries. So the requests are coming in, and you see that the request rate has also gone up. And apart from that, this is the replica that got provisioned, and it's actually running the doc search API.
Yeah, and so you've basically been able to stand up your function app in your Azure Container app, make it fully scalable, add in CI/CD in both GitHub Actions and Azure DevOps, and put in monitoring and observability around it to know what's going on. So we could see when you were pinging the function app, when you're calling it, and then see all the performance around it. So that's all really cool. That's like literally invoked all the DevOps processes from everything beginning to end, and also from Azure Container Apps. If you already have an existing Azure Container app and you're not doing this net new, you can also go in and connect it to an existing GitHub repository. So if the code exists and you have existing container apps, you can actually go backwards. We have a deployment. They've changed the name of it. I want to call it Deployment Center, but I know we've rebranded that something else this time. But you can then hook into your GitHub repo, kind of going backwards effectively, and then still have all these things hooked in. So that's really cool, Ramya. And the function, called, didn't have any delays. Enabled us to search across all of our multiple components, because I think the reality is a lot of us have multiple places where we have stored files, especially in like legacy systems, whether that's in GitHub, file servers, databases, etc. That function can literally query across all those things to then return the data you're looking for, saving you a ton of time. It was pretty easy to set up.
Yep. So going back to the slides, so you've seen how we've deployed function app in this microservices environment, and how the query invoked the serverless cloud native microservice function app to retrieve the query results. So yeah, as you can see, you can leverage the power of this app environment without having to worry about managing and maintaining your underlying Kubernetes layer, and also the networking part and observability part specifically for each app or a microservice that you're in scope which is being deployed. So you could only focus on the code and deploying it so that you could innovate faster and bring in value to your end customers.
Awesome.
So you must be wondering, like, when to use Azure Functions. Like, there's so many plans out there. If not, that's still no problem. But I just want to touch upon, right? Like, when do you use which plans for what? This is just guidance, and it purely depends upon your requirements as such. But usually the consumption plan that's out there, which is actually optimized for serverless scale to zero, and it is suitable for event-driven, functions native workloads as such, where you could deploy to this Azure Functions PaaS service as such, and to get the benefit of the scale to zero feature. And then you have Azure Functions Elastic Premium plan, which is ideal for workloads that are running continuously. So this plan offers that event-based scaling and network isolation. And there's also Azure app service environment, which is the apps which comes under the app service plan. So this is a fully isolated, dedicated environment suitable for workloads that need large queues. Or if you need to co-locate your web apps and function apps, then you could consider this. And Azure Functions on Azure Container Apps is suitable if you want to run functions with other microservices. And if you have this container apps environment and you want to bring in that event-driven capabilities using containers, then you could consider this option. So as you can see, right, like Function offers various plans and hosting options to meet your ever-changing business needs. So if you would like to run functions along with other APIs, web apps hosted on containers, then functions for container apps or functions for microservices running on ACA is the option that you consider.
Awesome.
So yeah, we're actively working on bringing out new capabilities. So we're coming out with seamless integration with Dapper. It will be out soon. The private VNet capability that we talked, and the managed identity will follow soon. And you can deploy functions on ACA using easy CLI, ARM templates, Bicep templates, Azure Portal, and CI/CD tools like GitHub Actions and Azure Pipelines today. And we're working on bringing in more client tooling support like VS Code, AZD, Terraform. So they'll be out soon. So yeah, check out the service and features that are available, and let us know what you think. Give us your feedback, what worked. So we're going to drop in we have a GitHub repo where you could post in your feedback or issues, and we're out there monitoring that channel very closely. We're also bringing in ton of samples, and we have Azure Docs having a lot of quick start examples as such. So really encourage folks to try them out, and yeah, hope this was helpful.
Awesome. Yeah, and we're going to put all these links down for everyone to see in the description of the show notes. So you'll have access to the GitHub repo that the product team listens in. We'll give everyone the link so they can get started with Azure Functions on Azure Container Apps, see all the options. I mean, there's tons of options with Azure Functions. They are pretty much limitless, which is why I love them. So Ramya, thank you so much for joining us today. It was great to have you on. It was great to play with Azure Function, Azure Container Apps, and see all the DevOps practices, all the getting started quickly stuff. It was awesome. So thank you for joining us. And for everyone out there watching, please feel free to put down comments, any questions. Robbie and I can answer, and then also reach out to the product group in the GitHub repo. So thank you, everyone.
Thanks, everyone. Bye.